Hello, students. This is Shakil, physics teacher, and today we are going to study something from IGCSE Physics 0625, and the topic is from General Physics, that is work, power, and energy. This is very important topic, as you know that the most important thing in human life is energy. So how we have to deal with this energy and what content, important content about energy is included in the syllabus, we have to look at it now. So this chapter is including 3 video lectures. The video lecture number 1, this current lecture is about 1.7.1, which is energy, and it's different types. Let's say in the core topic, we will identify many types of energies like kinetic, gravitational, chemical, elastic, nuclear, and internal energies. And then we will see that how this energy is going to be transferred or converted during various processes, like during mechanical working or during electrical working, or by heating and by waves. Then we have to study the most important principle, which is principle of conservation of energy. Everyone, I guess, knows the statement, energy can neither be created nor destroyed. It only changes its form, and total amount of energy always remains conserved. Okay. Well, in the supplement topic, we'll be looking at the expressions for kinetic energy and gravitational potential energy, the famous one, half mv squared and gh. And then we will apply principle of conservation of energy to multiple stage situations. And in the last, we have to look for the dissipation of the heat energy. And at the end, we will solve some questions from CAIE exam papers. Okay, let's move on. And then the next thing is this 17.1.7.2. This will be in video lecture 2. This will include an electrical energy and efficiency. And the third video lecture is about work and power. So let's start off with the energy. So we know about energy that it is the ability of object to do some work. And its SI unit is joule, written with J. Some people pronounce it as joule, and someone say joule, whatever, like it's complicated thing. We have to denote it with letters J, capital J, because it is named after the scientist. Talking about the type of quantity, yes, it is not having any direction, so it is a scalar quantity. And if you have some energy, only you can do some work then. Okay, and the types of energy, there are many types we have to study. The first one is the mechanical energy. The mechanical energy is further grouped in 2 energies, kinetic energies and potential energy. While this potential energy is further subdivided into, well, a lot of subdivisions, but we have to do that. So the first form of potential energy is gravitational potential energy, and the second form is elastic potential energy or strain energy. Okay, the next is kinetic energy, which is form of mechanical energy. We have to study it in depth. So let's look upon its definition. It's the ability of object to do work due to its movement or speed. Or there's the alternate statement, it is energy possessed by moving objects. So all the moving objects, a vehicle, electron, moon, our earth, satellites, aeroplanes, so everything that is moving is having kinetic energy, because the word kinetic means movement. Talking about its equation, it's quite simple. Kinetic energy is half mv square. And let's just give it a different color now. So kinetic energy is half mv square. Ke is the kinetic energy. Its unit is joule. M is the mass of object. And remember, it is always measured in kilogram. So if the mass is given in gram, you will be converting it into kilogram. For V, it is speed of the object, and it should always be in meter per second. Remember, we always use SI units for the calculations. Okay. Okay, now getting back to the factors now, the factors are the things that can affect a physical quantity. So we have to look for the factors of the kinetic energy. The first factor is the mass of the object, and the second factor is square of the speed of object. Of course, when you consider one factor, you will consider other as the constant. Like you can change the mass, but keep the speed constant. So bigger mass, greater kinetic energy. Smaller mass, smaller kinetic energy. And same is with the speed. Okay, moving forward to an example now. Uh, well, the example is an object of mass 500 gram is moving at 20 kilometer per hour. Well, straight away a lot of conversion because mass is in gram, which is not SI unit, and speed is in kilometer per hour, which is neither the SI unit. So what you have to do is you have to find its kinetic energy. Well, interesting. Let's look how we'll do that. Okay, so first of all, you'll write the formula. Kinetic energy is half mv square. Put the mass, but you have to divide it with 1,000 because you have to convert it in kilogram. And then the speed is 20, but wait. Let's see what's over there. 20 into 1,000 divided by 1 into 3,600. Well, why we are doing that? The question only 20 is there, but you'll see it stop. It's the kinetic at kilometer per hour. So we have to use in meter per second. So let's convert it into that. And you multiply speed with 1,000 and divide it with 3,600 to convert that in meter per second. And don't forget to take it square. So when you solve it, you will get this answer of kinetic energy, which is 7.72 joules. Okay. Well, let's move on to another situation linked to the factor. If mass becomes double, state new kinetic energy at same speed. Okay, so if for the above object, its mass is double, like it is now 1,000 kilogram, 1,000 gram, what should be its kinetic energy? So we know that kinetic energy is directly proportional to mass. So as mass is doubled, so kinetic energy would also be doubled. So to double it, so you'll get the answer of 15.44 joule. Okay, let's move on to next thing. If speed becomes double now and keeping mass constant, so what would be the new kinetic energy? So we say, okay, no problem, it's easy. We know that kinetic energy is proportional to square of the speed. So if the previous kinetic energy was 7.72 and you are doubling the speed, so wait and see, you are doubling the speed. But the thing is, it is square. So when you double it, so 2 square 2 is 4. So we'll say, okay, this kinetic energy will be up by 4. So that's why we multiplied it with 4 and you got new kinetic energy, which is 4 times the original, which is 30.88 joule. Okay, now what you have to do is what you have to do is you have to stop the video. You have to stop the video and then you will solve the question yourself. Okay, so a car of mass 1,200 kilogram moving at 72 kilometer per hour changes its speed to 36 kilometer per hour. So you have to find the change in its kinetic energy, right? So pause the video and solve it yourself. And the solution is on next slide. But once you're done, then play the video to look for the solution. So remember, mass is in kilogram. The speed was 72 kilometer per hour and then it changed to 36. Of course, speed decreases, kinetic energy decreases, but how much is the change? So let's see the solution. Okay, so kinetic energy is like half, it is actually the change in kinetic energy, right? It is change in kinetic energy. Okay, so it is like half mv square minus half mu square. The u initial speed was 72, so you convert that into meter per second. And then v was the final, which was 36, and you converted that into meter per second, so you got the values. In the meanwhile, you took 1/2 as the common, so it is v square minus u square, and then you insert all the values, 20 square minus 10 square, and then you got 180,000 or 180 kilojoules. That's the kinetic energy. I hope you got the same answer. Okay, moving forward to next important energy, which is potential energy. So potential energy is energy stored in the object due to change in position of the object inside a field. And there are three types of potential energy. The first one is gravitational potential energy, the most common one. The next one is elastic potential energy, and then electric potential energy. So we have to take review of all of them now. So if you look on gravitational potential energy, it says that this is the energy stored in object due to change in height inside gravitational field. And its formula is mgh. The factors are GPE proportional to mass, bigger mass, greater kinetic energy, greater GPE, and then GPE proportional to height. If you take the object to greater height, more GPE will be stored in it. Okay, the next one, let's color it a bit different, is elastic potential energy or strain energy. So this is the energy stored in elastic objects due to change in the length. Like if you compress a spring or if you stretch a spring or rubber band, then elastic potential energy or strain energy will be stored in it. This will be the definition as well. So elastic potential energy is 1/2 F into delta L. Delta F is the applied force and delta L is the change in length. Or elastic potential energy is half K delta L square. K is elastic constant or spring constant, and delta L is again the change in length. Okay, the next one is electric potential energy. This is energy stored in a charge inside electric field. And its formula is half QV square, where Q is the charge measured in coulombs and V is the potential difference measured in volts. Okay, so the next energy is internal energy. Internal energy is the sum of random distributions of kinetic energy and potential energy of molecules of a substance. So internal energy is sum of kinetic energy plus potential energy of molecules in the substance. So these kinetic and potential energies are of molecules. So we can also say that thermal energy or heat energy is also used for internal energy. So these are synonyms: internal energy, thermal energy, heat energy. The next important energy is chemical energy. Chemical energy. So chemical energy is the energy stored in molecules of a substance. And the examples are food, human, like ourselves, we are human, of course. Cell, batteries that we use in remote controls, in mobile phone and all that, even in car battery. Fuel, coal, oil, gas. Wood, matchstick that we use to blow up the stove to cook food. And then the firecrackers. On different occasions and parties, we explode them to create like sound and light impacts. And then the explosions, well, these are dangerous. Explosions all have explosives, sorry, all have chemical energies. So these were some of the things in which chemical energy is stored. Moving forward, nuclear energy. This energy is stored inside the nucleus of certain elements only. So a process called nuclear fission, in which you break a heavy nucleus to two or more smaller nuclei, and the other process is nuclear fusion, in which you fuse or combine two smaller nuclei into heavier one, is used to extract nuclear energy. Like nuclear energy is stored in the nucleus of every not every, but certain element. And if you want to harvest that energy, if you want to get that nuclear energy, you want to do two processes, either nuclear fission or nuclear fusion, to get that nuclear energy. Otherwise, you'd not be able to get that. Okay, what are the uses? It is used for mass destruction, like in atomic bomb, well, the scary thing, the Hiroshima, Nagasaki, and making the electricity to make our life comfortable. Of course, everything depends on electricity nowadays. And in medical and industrial purposes, we also use nuclear energy. Okay, moving forward to the next thing, which is energy conversion. You know that when after Big Bang, universe was created, all of the energy was given to us. So in the universe, we have a fixed amount of energy and we keep on converting that energy to fulfill our needs. So whenever energy changes its form, useful work is done. So certain machines or devices are used to convert energies between different forms. Let's say if you talk about car, so the purpose of car engine is to convert chemical energy of fuel into kinetic energy. So that will be utilized to move us between different places. If you look on the examples, there are various sets of examples, and these are very important examples from exam prospect. So you need to be very carefully listening to all these. So one, the object starts moving due to a force. So let's say this object was at rest. So its kinetic energy was zero. But then you apply a force and this object starts moving. So it is having some kinetic energy, but wait, from where this energy, kinetic energy is coming? Due to the work done. So the work that you will do on this object will be converting in the kinetic energy of the object. Okay. Okay, the next thing is object coming to rest due to a force. So let's say this is object of mass m, a force F was driving it, moving it with velocity v, and at that instant, its kinetic energy was half mv squared. But then we start applying the brakes, like the friction force opposite direction to the velocity, and after some time it comes to rest. So when it comes to rest, kinetic energy is zero. But wait, where this kinetic energy is gone? So the kinetic energy possessed by moving object is converted into heat and thermal energy or work done against friction or braking force. So we say that input energy was kinetic energy and the output energy once it stops is actually work done against friction, or it is dissipated in the form of heat energy. Number three is object moving on horizontal road. So let's say this is a horizontal road and object is moving on it. So there can be two situations. One, accelerating object. So if an object is accelerating, it means it is speeding up. Its speed is increasing. That means the chemical energy in the fuel, of course, which is used to move it, is converted into kinetic energy of the object. And if the object is decelerating, then kinetic energy of object is converted into internal energy or heat energy or sound energy. Example number four, moving objects uphill. So let's say this is an object moving with velocity v, and this is moving uphill. So of course, when it is moving uphill, after every instant, it is getting more and more height. Okay, so it is moving uphill, and two cases again. One, if it is moving with constant speed, it means its change in gravitational potential energy, a change in kinetic energy will be zero because speed is constant. So when speed is constant, it means its kinetic energy is not changing. Then all of its chemical energy of the fuel is used to gain GPE as height is being gained. And secondly, if it is accelerating, if it is moving with increasing speed, so then kinetic chemical energy is converted into kinetic energy plus gravitational potential energy because it is gaining height as well and it is gaining speed as well. So both the energies will be increased. Okay, the next one is number 5, which is electrical energy in circuits. So let's say this is the cell. You know, cell is having chemical energy and you connect it with a lamp. So the cell converts its chemical energy into electrical energy of the charges, and when those charges pass through the lamp converts electrical energy into light and heat energy. So chemical energy in the cell to electrical energy in the charges, it is converted into light and heat energy. Number 6, burning of fuel. That's common, very common. The fuels like the oil, coal, gas, wood is having chemical energy, and when you burn it, that is converted into heat energy, and light and sound are also produced. Number 7 is energy conversion by radiation. So we know about sun and stars that they emit electromagnetic radiations, and infrared rays transfer heat energy and the visible rays create visibility. So let's talk about heaters. Let's say this is the cell, which is number 1, and number 2 is the wire, and number 3 is the heater. So in cell, chemical energy is there that converts into electrical energy, and when that electrical energy passes through heater, it dissipates heat energy, which is in the form of radiation or infrared rays. Okay, then number 8 is energy dissipations. At times, one form of energy is converted into two or more forms and spreads away in the surroundings. So that is known as energy dissipation. For example, falling ball towards ground. If you drop some ball on the ground, initially when you're holding it at some height, it is having GPE. And when you release it, it is falling down. The GP is converted into kinetic energy. And when it strikes the ground and it comes to rest, then all of the kinetic energy is converted into heat and sound upon impact with the ground, and that dissipates. That is known as dissipated energy. Like the heat and sound will spread out in the environment. Number 2, ball hitting a glass panel. Let's say if you're playing a cricket and you smash the ball for a 6 all of the way, but well, it got into the window panel for the neighbor and the window panel is broken down or shattered. So then the kinetic energy of the ball is converted into heat or sound energy upon impact with the glass. Wow, you must be hearing the sounds in the background. Well, someone is hitting the ball in the glass panels. Okay. Well, let's look on the most important principle of topic energy, principle of conservation of energy. Everyone knows the statement, energy can neither be created nor destroyed. It only changes its form, while total amount of energy always remains conserved. That's what I told you at the start, that when after Big Bang, universe was created. So we got a fixed amount of energy. And from that day, we keep on converting energy between different forms. Okay. Now let's look on the mechanical energy conversions. Number 1, falling ball. So when the object are dropped from a certain height, their GPE will be converting into kinetic energy. So let's look. Let's say this is the ball, which is at rest initially. So its speed is 0, kinetic energy is 0, but as it is held at some height, so its GPE is mgh, which is maximum. So it is held at highest point. And when it is dropped, it is start moving downward. So it's, and keeping in mind there is no air. So when the object is dropped, its height is decreasing. And when it is near ground, its height is 0. So GP is 0, but its speed is maximum. So kinetic energy is maximum. So we can say that GP on top is equal to kinetic energy at bottom, like mgh is half mv square. Similarly, for second case, when the object is projected or thrown upward, we say kinetic energy at bottom, which is half mv square, is equal to GP on top, which is mgh. So very simple. Let's say you are throwing a ball of mass m with velocity v, moving up, it is slowing down, and at highest point it comes to rest. So it stops, kinetic energy is 0. But as its height is maximum, so its GP is maximum. So now let's start solving this example. A ball of mass 200 gram projected upwards at 20 meters per second. Find the height gained by the ball if air effects are ignored, like no air resistance. It's quite simple. You know that kinetic energy at bottom will be converted into GP on top, half mv square equal mgh. As both the m are same, so you can cancel them. And then half into 20 square, which is p square equal g is 10 into height. So simplifying it, we get 20 meters. So the ball will gain height of 20 meters. Okay, let's solve some past paper practice questions from this topic. There are 3 MCQs, so let's read them. Horizontal force pulls a box along a horizontal surface. The box gains 30 joule of kinetic energy and 10 joule of thermal energy is produced by friction between the box and the surface. How much work is done by the force? Well, that's quite simple. We know that the work done is equal to change in energy. And there are 2 types of change in energies. One is kinetic energy and the other one is thermal energy, right? So we say that as kinetic energy is 30 and thermal is 10, it means the work done will be 40 joule. 40 joules, so option D. The next is Which situation involve no work being done and no energy being transferred? Like no work is done, so no energy is transferred. So you can pause this to check answer yourself and then play it to see your option is correct or not. So we have to see where no work is done or no energy is transferred. A car skidding to stop the road. Well, work is being done by brakes, so this is not the option. A crane lifting a load. Well, as the load is being lifted, so GP is being gained, so this is not the option. A heavy load hanging from a strong bar. So the load is only hanged. It is neither moving nor raising. So it means this can be our option because no work is done or no energy is transferred. And D, a student dragging a big box over a rough floor. So yes, he's doing some work. So we'll say our option is C because the box is only hanging. Like this box is only hanging. So it is neither moving nor lifting up. So no energy conversion is there. Okay, let's look at number 3. A stream flows out of a lake and down the side of the hill, which best describes the changes in the energy stores. Okay, so water is falling from the height of a stream down the hill. So when the water is falling down the hill, of course, it is striking with a hill, and it is GP. It is like gaining heat energy. Okay, so if the water is at some height, let's say like this is the hill and water is coming from a height. So it means initially GPE is there. So we'll say, okay, the A is not the option because kinetic energy, GPE, yes, GP, yes, and these kinetic energy, no. So now look on B and C. So gravitational potential energy is converted into kinetic energy plus internal energy, seems to be correct. Gravitational potential energy plus kinetic energy is converting into internal energy. No. So it is option B. It is option B because the GPE is converting into kinetic energy when the water is falling down. It is gaining speed and it is gaining internal energy due to collision with rocks. Okay, let's look at this theory question. This is from the most recent paper, May 2021. Okay, figure shows water flowing at very slow speed over a cliff edge. Okay, so this is water moving down and it is 15-meter height. Some rocks are there at the bottom. Water falls 15 meter onto the rocks below. Show that the velocity of the water when it strikes the rock is 17 meter per second. So we will say that GPE on top is equal to kinetic energy at bottom. So GPE is mgh and kinetic energy is half mv squared. So as both the sides are having mass, and mass is not given in the question, so mass will be cancelled away, and you have to find speed. So shift 2 to this side, 2gh equal v square, and then take the square root. So you will get v is 2gh square root. Just plug in the values, 2 into 10 into 15. It is 300. And when you take the square root of 300, it is around 17 meter per second. So that's your answer. The next is 30 kilogram of water flows out the edge every second. So T is 1 second and mass is 30 kg. Calculate the force exerted by rocks on the falling water. Ignore any splashes. Like when the water is flowing down, how much force the rocks are exerting on the water to stop it. So we say that force is change in momentum over time. Change in momentum is mv minus mu over t. Okay, so we will ignore, let's say its final velocity will become 0. So mass in when water will hit the rock, its final velocity will be 0 minus mu over t. So we'll say, okay, it is F is minus mu by t. So minus and mass is 30 and initial speed is 17. When it hits the water rock, its speed is 17. Every second, time is 1. So it means force will be negative, and then you multiply them to get your answer, which is 30 into 17, 510. So minus 510 Newton. So you can ignore the negative sign. So your answer is 510 Newton. So thank you, students. I hope that you have viewed it carefully and you have made your notes as well. If not, take a review again and make your notes. The next video is video lecture 2. It's about energy efficiency. And the third one is about work and power.